Okay, good afternoon. We'll go ahead and get started. It's 4:02 p.m. Eastern, so let's get started here. Uh, my name is Chris Elam, so I'm the East Central Service Advisor. So I handle Rheem, Sure Comfort, Weather King, Mitsubishi, and Climate Master. I was a dealer for a few other big name brands. So if you ever have any questions, a lot of times I can help you out with those as well. Um, and I basically ran service on and off for about 20 years. Owned two businesses, still ran service and tune-ups on a daily basis practically. So that's kind of where my bread and butter, my concentration is. So this class here is going to be kind of geared towards a lot of the basic stuff for tune-ups, new tune-up techs to where they can get into some good habits, as well as some older techs, to kind of get in better habits. Because every year, every fall, every spring, tune-ups, guys, after you've done it for a long period of time, you don't necessarily look forward to doing those. They're kind of monotonous, and if you provide good service, you can make customers. If you provide poor service, then you can actually lose customers on tune-ups. But they are a good way to build your business, and then also uh, maintain your business, and then also a good way to make some money while you're doing it. So take advantages of customers' concerns if they're looking for different products or issues they're having. That's the time to address them. So, like I say, a lot of this may be kind of basic to a lot of you. Some of this will carry into service calls as well. We'll get into a little bit of brazing, some diagnostics and things like that. So we'll go ahead and get started here. If you do have any questions as we go along, everybody should be muted because it's a little hard to talk and with background noise. But in the chat feature there, I did put my name, my phone number, and my email. That's my direct cell phone. Actually, that is my direct cell phone. Let me put my work phone in there. So that's my work phone there, the 661-281-2881. So that's the number to call me at. That's my email. If you have any questions as we go along, feel free to put them in the chat, and then we'll kind of bounce back and take a look at if there's any questions. So we'll get started here. Okay. So I was always real big on arrival and preparation. If I'm going to a sales call, for instance, I used to listen to a lot of sales, Charlie Greer sales tapes, different sales tapes to get my mind on what I'm doing, prepare myself. So it's best to prepare yourself as you're going there. Also understand what you're there to do. Is it a service call? Is it a maintenance call, or is it an installation? Very often, a maintenance call will turn into a service call. People that have issues, they'll claim they just need a maintenance or a service, and they think that's going to take care of it for them. So be aware of that as well. Do arrive on time to the best of your ability. I know everybody's schedules usually in the heat of spring and summer, it's pretty tight. A big one that I'm a hard believer in: look professional, act professional. Show up, be in some sort of a company uniform, t-shirt, shirt, sweatshirt, whatever. You probably don't want to show up in cut off shorts and a Budweiser tank top. That kind of sets the tone for the call. And a big one is listen to your customers' concerns and possible system-related problems. What I would always ask is, are you noticing anything out of the ordinary or any issues? If they're noticing something, It may be something, it may be not much at all. But if you don't ask or if you don't listen to what they're saying, like say, may say they're having low airflow or any number of things. So pay attention to what they're telling you, what their concerns are, because that could be a possible way to turn that into, I mean, you name it. Indoor air quality could be a new system, could be a pretty severe cleaning, could be a new motor, you know, you name it. And always have the proper tools. Now this picture here just kind of has a conglomeration of stuff, but I mean, a couple of guys used to know, they used to have their tune-up bags. You know, it would have them exactly what they need for a tune-up. So do make sure you have your required hand tools, drills, gauges of some sort, whether it's digital or analog, whatever, and do have a good quality meter. Recommend having a dual port manometer or even a single port manometer with some pitot tubes for static pressure. Good clamp thermocouple and a garden hose. If you're doing tune-ups on a regular basis, I got to the point where I was carrying those flexi hoses. So I'd carry 2 50-foot flexi hoses and a bucket. So I would use whatever hose I need, you know, let it drain out, throw them in the bucket. Instead of winding it up and getting water in your van. So I would carry in my bucket a couple rags to wash off the unit, a spray bottle with some cleaner, my coil gun, and 2 hoses. So I could do a lot with just carrying a solitary 5-gallon bucket. If you're going to get the flexi hoses, don't get the green ones with the plastic fittings. Get the black ones or whichever ones that are using the brass or the steel fittings. They'll last you a lot longer. Do carry nitrogen to clear out drains if needed. Also carry an ECM motor tester. That will make your life a whole lot easier than trying to troubleshoot without. And they've got some cheap ones out there. Gentech makes one that will do the old 16 pins as well as the new ones. Supco's got a new one. I think it's about $60 that does both the old 16 pin and the new as well. And then additional tools. A lot of guys carry whatever you think that you may need to do a appropriate tool, appropriate tune-up. The more time that you can spend on the tune-up and not running back and forth to your van, the better it is. As you get into Fieldpiece, I do like Fieldpiece. Use their meters for years. You get into the higher end Bluetooth that you can link to JobLink. JobLink, you can use your meter for JobLink. This digital manifold will link to JobLink as well as these Bluetooth gauges. So if you have any combination of those, they also have the Bluetooth temperature probes, which will link into JobLink that will give you a complete picture of what's going on with the system. Plus, you don't lose any refrigerant because you're screwing directly onto the service ports. Some new products that make life a whole lot simpler. These big umbrellas here, a couple different makers make them. Has a very large magnet that you can stick right on the air conditioner or rooftop. It'll even tilt to accommodate you. That has a 60-inch span. So if you stick that right on top of the air conditioner and you're working underneath it, chances are you're not going to get wet. If you do, it's not going to be much. And that'll also work pretty well on a hot day, changing the compressor, you know, staying out of the sun. Those are, I think they're about $50-60. Well worth the money. You know, I never minded getting wet. I just didn't want to get my tools wet. So this will help that. Also, you have this piece here, which is your compressor cooler, if you will. Screw your garden hose onto the end of this thing here. This is a magnet. Stick that right on the compressor. If you have an overheated compressor, turn your water hose on. Now it's actually flushing and cooling your compressor hands-free. Nothing worse than trying to cool a compressor and just stand there and keep your garden hose on it. This takes that out of the equation. It's magnetic. Don't know how much that is, but it would be a good tool to have, especially in service. And some air purification. I'm sure you guys are selling these already. The Remy Halos, Remy Halo LEDs. You have the iWave Rs, both excellent products. With COVID and everything that's going on, everybody wants to be healthy. These are great upgrades. Customers are usually asking what kind of products are offered or what can you do to help them with that. So that's definitely something your techs want to be well versed in and have the ability to offer. So kind of get into, this kind of goes for tune-ups and service calls. Tune-ups more or less, as you're doing an AC tune-up, pay attention to the furnace components as well. You're right there, you're looking at them. Take a look at the heat exchanger. You know, I don't know how many bad heat exchangers I've found through the years on tune-ups or AC calls because I took the few extra minutes to look at it. So that's huge. Also indoor air quality opportunities, the iWave and the Remy Halo, and there's other brands as well. You know, people will ask you about those. That's a good time to offer those. Now, also while you're there, as you're walking up, as I'm walking to any indoor unit, first thing I do is do a visual inspection of the venting, whether it be PVC or metal. Because a lot of times you'll see metal that's been rusted through or taped shut or just big gaping holes in it. So not that you're there to inspect the vent, you know, to do any kind of repairs on the furnace, but there's an issue there. So that's an opportunity to correct that for the customer, also make some money. Also take a look at ducting, just do a visual, you know, look at that. If anything looks crazy out of line, make notes of that and offer corrective actions if necessary. Also plumbing issues. Some companies, a lot of companies do plumbing as well. If your heating and cooling guys see a plumbing issue, that's a nice transfer over to your plumbing department. Even though my companies didn't have plumbing, you know, I sold a lot of plumbing jobs for plumbing guys that I knew because I would see problems, note it to the customer, and refer them to whoever, you know, whoever I wanted to refer them to. So just don't have tunnel vision, you know, look at the big picture while you're there. And what I've learned through the years is develop a routine. I do the same thing. I did a tune-up, I think it was 2 Saturdays ago, for an old customer that only wants me to do it. I do the same routine that I do now as I did, you know, before I took this job over 3 years ago. A good routine will improve time management. I mean, all companies are different. Some companies will give you 30 minutes to do a tune-up. Some of them will give you an hour and a half to do a tune-up. But time management is important. You want to make sure that you do a good, thorough job in a good, timely fashion. And do ensure that you cover all necessary components every time. And that should be documented within your invoice. If you start missing components or taking shortcuts, eventually it'll come back to bite you. And then what that does is that develops good habits. Good routine, good time management, cover all the components. Customer gets a really good, thorough tune-up. They're happy, you know. And as a technician, you get your hours in, so it's a win-win. The documentations is important. Years ago, we hand wrote every invoice. Then we got to the point where we used to do them on a phone and print them out in our vans. But I would write little books practically of detailing every single thing I did. Something happened, something came up down the road, they would go to my invoice and I would note whatever it was. It would be in detail what was done, so there was never any issues. So provide a thorough explanation of what services were performed, what you did, what you found, detailed description of any issues that you find. That's important. Make special notes of urgent issues and corrective recommendations. Just because you tell the customer what you found and they'll agree with you, doesn't mean that you just told them you had the conversation. Because if something happens in a week, 2 weeks, whatever it is, they will forget they had that conversation. So if services are not detailed, this is a big one too. Say you checked the dual capacitor and it was fine, or it wasn't fine. But if you didn't detail that on the invoice or your however you do your invoices, customers can use that against you, and they can assume it wasn't done and use that against you down the road. But make special, like I said, I can't stress that enough, detail every issue, because you not only want to protect yourself, but you want to protect your company. And in the process, you're also protecting the customer. So if you find issues and you make recommendations, and the customers, if they're not well, I should say this: if you make recommendations and you don't document them, they will come back as a callback because there's no details regarding your recommendations. But if you document recommendations and they're declined by the customer, they're not callbacks. They turn into billable calls. If you recommend replacing a dual capacitor and they decline it, 2 weeks later, dual capacitor goes bad, that's not a callback. That's a billable call because you recommended to replace it, they declined it, so now it's on them. Because you really, as a technician, service person, you want to protect your company, protect you. You want to reduce callbacks as much as possible. Callbacks are killers, especially when it's hot, when it's cold. So this one's on maintenance. Why is annual maintenance important? Couple reasons. One, there are specific items on both furnaces and air conditioners and heat pumps that are, if not maintained properly over time, they will, cause you nuisance calls. Think about furnaces, flame sensors, drains. Same with drains in the summertime. So it's important to keep this customer's system clean and running properly. Also, it gives them a sense of safety because they think it's been cleaned, it's been serviced. It puts them at ease. Another big one is it keeps guys busy during the spring and fall. If you don't have service, maintenance to do, you're sitting at home riding the couch, not making any money. And it's also important to keep the customer base going for the company. Maintenance customers, if they need if something major fails, they'll not most generally use the service maintenance company, providing they've been good quality service. So it's important. It's a win-win all the way around. Like I say, even though as a technician, they're kind of monotonous, make them fun, use them to drum up additional income, show extraordinary service, make the customers happy. Now, a lot of this comes from the way I do things, the way I recommend things being done. So you think about what items should be addressed on an AC maintenance calls. Everything associated with an AC and heating system. You're there. You got your eyeballs on all of it. I'm not saying you have to clean and service every component, but you want to make sure that you check over everything and you document that. Another big misconception is, I was taught this years ago, we put gauges on everything. You know, it didn't matter what it was. You put gauges on everything. Now, through the years, people got smarter. Um, you don't need to put gauges on everything. If I have two empty hoses and I go put gauges on it, you know, Bob comes back in a month for whatever reason, puts gauges on it, or next year, then Tom comes. Well, pretty soon after 3 or 4 visits, because you're losing so many ounces for for every time you put hoses on there, all of a sudden the customer thinks they have a leak, and they don't. You were just losing refrigerant from putting gauges on and taking them back off. So don't put gauges on everything unless you think there's a problem. And this is a big one for me. Always verify drains are clear and free flowing. Can't preach that enough. I was sued once because of a drain. Turns out that, you know, I did my portion of the drain, and because I had like 7 years of documentation of clearing drains for them and everything was detailed, that they didn't, you know, it went in my favor. It wasn't my fault, but had I not had all the documentation uh, and did things every time the same way, it could have went the other way for me. So also when it comes to drains, um, there's nothing worse than, you know, Bob went out there and did a tune-up. 2 weeks later, John's out there and you got a backed up drain, water everywhere. You know, drains don't back up that quick. Sorry. And a small drain backup can easily lead into a $10,000, $25,000 water claim. And if you get a couple of those on your, you know, your insurance policy, your liability policy, it goes up very quickly from there. So always make sure your drains are clear and free flowing, which I'll kind of get into in a little bit on that. So on your general indoor section, whether it's furnace or air handler, first thing I'm doing is I walk up to the unit. I use a spray bottle with Fabuloso, some shop towels. I'm going to clean the entire outside of the cabinet or air handler. I'm going to clean the doors. Anything that's metal that I can see, I'm wiping it down. So, you know, if in a month the customer looks at the furnace, it's like, wow, there's nothing on it. You know, it looks clean because it is clean. So I'm going to clean the furnace, air handler, and cabinet. That should take you literally just a couple minutes. Not even that, actually. You know, 2 minutes tops. Also, once you get in the habit of cleaning them and they're perfectly clean, guess what? When you come back next time, you don't even want to look clean again. So you just have to kind of redo it again to kind of straighten it up a little bit. There again, since you're at the indoor section, you want to do a visual inspection of ducting, drain, and venting. Does anything stand out? You know, if it does, make notes of that. And then drains. Now, this is the way I always do it. Some guys will use nitrogen. What I would always do is go to the highest point of the system, the highest point of the drain, and then I'll take, used to carry a little bottle of water, and I'd actually fill it up between calls. So I'm going to pour the water at the highest point of the drain, then I'm going to go to where the drain drains. And I can tell by how it's draining if it's clear or not. So if it's draining kind of slow, then I'm going to go get some hot water, you know, out of the sink from the customer, and keep pouring a few more bottles down there. And by the time I'm done, it's a free flowing drain, because I can pour it in, I can hear it perfectly coming out. Now, if you do that, chances of your drain backing up, you know, go to almost nil. So that's the way I do it, however you choose to do it. But you do want to make sure your drains are clear, verify they are free flowing. Check all your electrical wiring and your connections. By that I mean visually inspect the wiring, you know, hand check the connections. If you see something that looks damaged or burnt, what have you, that's something you want to address. And I'll do that for basically all the wiring: thermostat wiring, low voltage, motor wires. And a big one for the summertime is your indoor coil. So I will check on every service call I ran. I always check the indoor coils. That was step number one. Walk in, turn the fan on, check the filter, then I'm checking the coil. Check the indoor coil. Now, depending on what your policy on maintenance is, some guys will clean it, not a thorough, heavy, filthy cleaning, but they'll do a small treatment on it as part of the tune-up. If it's dirty, revert back to your company policy on the coils. Otherwise, if you do any kind of sanitization on them as part of the tune-up, sanitize that, treat your coil, treat your drain pan if that's what's included in that. But above all, make sure your indoor coil is clean. If it's not clean, take pictures of it, recommend it, but make sure it's clean. Next, you want to check your blower motor, check your outer air vents, make sure they're not clogged up with debris and junk. If it is, get that out of there. Also check your wheel, make sure it's not full of junk and buildup and debris. Just a 1/4 inch buildup on your blades can cause a 20% reduction in airflow. And then also take a look at your housing. If your housing's all nasty, chances are your wheel is going to be nasty. And if that's the case, chances are your indoor coil is going to be the same thing. There again, if you have a gas furnace, take a look at the heat exchanger while you're there. You're right there in front of it. I would do a static pressure reading. Get in the habit of doing that more and more, because with all these new ECM and X13 motors, they're very static pressure dependent. If you cause them to run under extreme static pressure, which is they want to operate 1.0 and under. So if you've got them working at 1.25, 1.5, you will burn the motors up. It can also actually do what they call a fold back. So if you run them so hard, they'll actually fold themselves back. So they'll slow themselves down to keep from overheating, which means you'll actually get less airflow. So it only takes a couple minutes to do a static pressure reading. I would recommend it because you can determine a lot of issues with the system. That may be something where they need additional ductwork later. Or it could be that they're using too restrictive of a filter. But you're kind of ruling out some things just by taking a 2-minute test. Always check the filter. If you replace the filters as part of the tune-up, by all means. If you don't, they want to purchase one, sell them one, or if it's their responsibility to replace it, note that on your invoice. So if it's not changed down the road, it's not a callback, it's a billable item. Also, always check the thermostat. And it is a good idea, really, before you jump into the furnace section. I mentioned it a minute ago, but when you first get there, go to the thermostat, turn the fan on before you start checking air conditioning and stuff. Turn the fan to the on position, the blower motor should come on. If the motor doesn't come on, make mental note of that. Tell the customer, hey, the fan's not coming on. Let me dig into this and see what's going on. Because otherwise, it was working just fine before you got here. So, and a big one here, this is huge. Years ago when I did this, we didn't have smartphones. We had Nextel, and at one point there wasn't even cameras on there. If they were, they weren't that good. This goes big for the office and future trips. Record the model and serial numbers of the units, filter sizes, and any additional air quality products. If they have a humidifier, get the correct one. April Air 550, whatever it is. So if the office or whoever looks back, it'll say, you've got a Rheem, R96V furnace with a 16 by 25 filter and a Aprilaire 550. So if they come back, they know exactly what filter size you need and what water panel you need or anything else, UV lights. And then do record the furnace location and any additional notable details. If it's in a really tight attic, you probably want to note that, or a tight crawl space, you want to note that. Or if it's up on a roof, you need a special ladder, you want to note that ahead of time so so they can send the appropriate person to do the job. Now, as far as your outdoor, as you're walking up to the unit, do a visual inspection of the outdoor unit. Anything jumps out at you, make a note of that. What I always did, like I said, I did carry my bucket, my cleaning spray. So I'm going to spray the top of the unit, clean it up, wipe it off with my rags, rinse it off so it looks nice and clean when I'm done, because it invariably has that green mold stuff on there. So just a couple sprays of cleaner, wipe it down. So I'm going to clean the outdoor unit cabinet, and then I'm also going to clean the electrical compartment. Nothing's worse than after a tune-up, somebody follows you up and there's a bunch of cobwebs in the electrical box. Doesn't give you the impression that it was cleaned or serviced very well. Also clean the outdoor coil. Depending on what your company's policy is on the outdoor coil, I would definitely clean it of some sort. So depending on what kind of coil it is, you may use coil cleaner, you may use just water, whatever your policy on that is, but ensure that the outdoor coil is clean. A lot of guys just zip right past that. When I go out on a site visit, one of the first things I do is I check that outdoor coil. All I have to do is kind of look up underneath there to see if it's clean or not. If it's not clean, first thing we're doing, we're cleaning that coil. And the last thing you want is if I go out there on a tune-up, do a halfway job, and then never fail, somebody else is going to have to come out there on a Friday night at the end of their day and then basically do for free what should have already been done. There again, check your electrical wiring and connections. Look at your wiring, look at your terminations. Do you see any bubbled up wiring? If anything like that's there, make notes of that. If you need to make any corrections or terminations, correct that. Note that on your invoice. Point that out to the customer. Whether or not you charge depends on the company. But if you don't charge, let them know what you did. That's a good service to the customer. Because what you're trying to do is build value. That's all it is. Everything we're doing here is a show. No matter how good you are or how bad you are, if you make it look good, customers will be happy with it. So they're paying for a good service. What you want to do is provide them good service. Always check your compressor and your fan. You want to check your incoming voltage. You definitely want to check your amp draw, compare that to the data plate, and then check the operation. Now that's kind of a listen and look type of deal. So if it sounds good, you're probably okay. But look at your voltage, amp draw, and operation. Always test capacitors and any kind of start components that you have. Those will come back to bite you. And then once you're kind of done with your cleanings, at that point you can fire everything back up, do a temperature rise. You're looking for something 16 to 20. 16 is probably the lowest you want to see, and 20 to 22 is what you want to see. Difference between the supply and the return. If you've got a 21 degree temp split, I wouldn't necessarily put gauges on because you probably don't need it because it's looking good as it is. But if you're at like a 14, you might want to put the gauges on there and see what's off with it. Inspect the contactor, look for any kind of burnt marks, loose plates. Also, if you have any defrost boards, check those over, check your wiring. And this is a big one, ensure all screws and service caps are installed. If you leave service caps off, you know, and anything, if you get a leak or anything happens, well, they left the caps off. I don't know how many times I've heard that through the years. Or they didn't put all the screws back in. They didn't put the caps back on. That's just poor service, and it's an open invitation for you know, free stuff, free repairs down the road. So these pictures here, believe it or not, were sent to me. I wanted to include them. This is on one of these new filterless systems. And that's what the customer was told. This is a filterless system. So this is the blower wheel, and this is not that old of a system. Looks bad, looks old. This is the blower wheel. So years ago, we had to just reach in there and pull that nasty stuff out of there and show it to the customer. Well, now you can get a smart camera in there and get you a good eyeball picture of it. So everything they breathe is going through this. You know, that's thoroughly unacceptable. So at that point, you know, I'm going to sell them I'm going to sell them a lot of stuff, but a complete cleaning filter system and all that. But that's a blower wheel cleaning service, or you can also sell them a new blower wheel, but that's just nasty. That there is also part of the new filterless system that the customer was sold, and that is the secondary heat exchanger on a 90% furnace. It's hard to even tell what it is, but if you look closely, you can see your blower racks right here, and that's your secondary. That's horrible. And again, this is the same system, and this is the A coil. So you can imagine that the system was not heating, it wasn't cooling. The customer paid a decent amount for this system, and then I'm thinking this is like a year and a half, something like that old. This is what they got, and they were told that they didn't need a filter. So, and you will run into similar issues like this. If you see something like this, if they don't want to pay the repairs, then you have to document every which way that system will not operate under these conditions. That takes the liability off of you and back in the customer. Actually, now static pressure is huge for me. I deal with it every single day. I've been testing for static pressure since probably 2013. I mean, I'll check it just about on every call I used to service. So, I mean, a lot of them were good, a lot of them weren't good, you know. But then I know if it's really, really high, then I know there's a restriction somewhere. Could be on the return side, could be on the supply side, could be a very restricted filter, could be a clogged coil. You name it. So, and a lot of times everything can be perfectly clean, and if your static pressure is way off, it may work right, it may heat okay, and it may cool okay, but it could heat and cool a whole lot better if it was correct. So I would advise you to check static pressure on every tune-up, especially every service call. And really, the installers should be checking it once they're done as well. But you can do this with, like, this is a dual port Magna Helix. You can use it with a dual port digital manometer, or you can do a single manometer. You know, check it one at a time. In this case here, they're checking just the furnace, because they're checking inside the filter and before the coil. So they're checking this right here. So they're checking the coil on and from the filter out. And if that was their actual static pressure, that would be phenomenal. So dual capacitors, my favorite summer repair. I used to carry dozens of these just for the hot weekends, and by the time the weekend was over, I was usually just about out and calling other techs to get their capacitors. You can test them and gauge them whether they're good or bad at that time, but they can still fail anytime, especially if it's hot or if you're in a area where you're prone to power surges. Big way is how to test. Two ways you can test it. One is to power down the unit, pull the wires off, discharge your capacitor, and then do a microfarad check on it. So this one here, for instance, it's saying 55, 7.5, 370 with a plus or minus 5%. So if it's 55 or 7.5 and it's below 5%, it's below the allowable capacity. That's going to cause extra load on your compressor, extra load on your fan motor. So if it's low, you want to recommend, I mean, you can use this label right here to show the customer, you know, and you can do it right in front of them to sell that. So if it's below the allowable percentage, recommend replacement. Also do a visual inspection. If you've got wires on here that are all bubbled up, chances are you have a loose connection there. And if you have what looks like a pop can or an exploded pop can where it's all bubbled up here in the top, then you know it's bad. It's shorted. Now the kind of the best way to check it is to test it while it's under a load. If you check it with the power off, but leads disconnected, you're just checking a sitting capacitor. But you can also check it while it's running, and that checks it under a load, so it gives you a little more accurate. The proper way to do that, basically you have your amps. So whatever you're checking, if you're checking the compressor, you're going to check the Herm wire. You take those amps. So we'll just say whatever it is, 10 times, this is a constant number here, and this will fluctuate slightly, but 2650. So you're going to take your compressor amps times 2650, and you're going to divide that by your voltage. Now that's actual voltage. So if you're checking common to Herm, don't check your 208, 230, because it's going to skew your reading. So you want to check your actual volts. So you're common to your Herm terminal here. So you're going to take the amps times 2650 divided by the actual volts, and that will give you your actual microfarads under load. And many times the difference between testing like this with the wires off and under load can be sometimes dramatic. Sometimes there's no difference or it's close enough, but it's a good idea to have this in your bag of tricks, because you can do that once you have the unit back up and running, your coil's drying, you can do that check. You got your contactor here, pretty simple here. You got your 208, 230, L1, L2 here. You've got your 24 volt coil here, 24 volt common. Over here you have your out. So in this case here you have your common to the compressor or fan motor, and you'll also have your common to the compressor. Over here you're going to have your run to the compressor and your run to the fan motor, and also your common to the dual capacitor. Now it is kind of, I've had this actually a few times lately, where guys are replacing compressors or replacing compressors and capacitors, where they're putting them in and they're not wiring this up exactly the way it should be. That can differentiate between, follow your diagram on your unit. But if you don't wire it up by the unit, a lot of times these guys are putting new compressors in and they're getting what appears to be lock rotor amps, because for some odd reason they're not getting their common over here to the dual cap. So it is imperative, if you get, in a case like that, you get lock rotor amps, come back, check your capacitor, make sure it's good. The next thing you want to do is check your wiring. Because if you cross, for instance, you cross your red and your black here to your compressor, it will give you what appears to be lock rotor amps. It'll go, it'll keep doing that. Just by switching these two, or not, ensuring that your common is on the capacitor properly. So our outdoor fan motors, very important. Watch for any kind of oil where your bearings are leaking here. Check proper voltage. That's huge. If you start exceeding 253, you will sustain damage over time to your condenser fan motor, actually your entire unit. But so that's why proper voltage is important. Also check your amperage. Your amperage will be on the side of the fan motor. It'll also be on the data plate. So if you're replacing a fan motor, it's important to, number one, know your rotation. Some of them you can change. Some of them are fixed. Also make sure your RPMs are correct. If you've got a low RPM and you put a 1050 in there, chances are you're going to overheat the unit. One other thing, I got burned one time by this. I had a bad capacitor and my fan motor was basically overheated. And I didn't really know that at the time because I was still young. These motors also, like compressors, have fan overloads in them. So if you're out there on a bad capacitor situation, don't jump right into a fan motor. It may just be overheated. If you can touch the case of the fan motor and it's really, really hot, you can bet that your overload is probably open. And then if you ohm out your wires, you'll find that your common is missing. And if the overload is open, just take a garden hose, spray it down. It'll reset. You'll be back in business. Look for oil. Listen for grinding or strange sounds, and then feel for vibrations. What we're getting into more and more here is the ECMs and X13 constant torque motors. This is huge. In fact, that's all you get on furnaces now. So you've got to become very familiar with this. Pay attention to noise and airflow. If it sounds like a jet engine in there, if it sounds like it's struggling and it's, there's an airflow issue, either on supply or your return. So if it sounds rough, get to the bottom of it pretty quickly.
Hey, Rojo.
Okay.
Don't pay buddy.
See.
Sorry about that. I had to mute somebody there. Okay, so yeah, pay attention to noise and airflow. With both ECMs and X13s, if you run them under extreme static pressure, you will burn them out, guaranteed. Used to have guys that they're on their third and fourth X13 motor, and they're like, well, these motors are junk. It's not the motors that are junk. It's the condition that they're running at. So if you run them hard enough, you will blow that little resistor in the end plate. So I recommend selling, before you sell new furnaces and ECM motors, especially on what could be tight duct systems, do static pressure checks. Find the problem before you sell the job, and then correct it. Some symptoms of high static will be excessive noise. That's huge. Also excessive amp draw. When I was first taught to sell ECM motors, ECM motors solved every problem in the world, and they cost as much as a light bulb to operate. And in a lot of cases, that's true. But if you're in a high static situation, you're taking that what you consider to be an energy efficient motor, and you're pushing it past its boundaries. So it's having to work 120%, 130% to move the air it thinks it has to move. By doing that, you get extreme excessive noise, your excessive amp draw. So whatever it should be, it's going to be double or triple in some cases. As a byproduct of that, you can end up with reduced airflow because it will eventually slow itself down. And you'll also end up with insufficient heating or cooling. So that's huge. This is the way it's going with the X13s and the ECMs. It's only going to be more and more prevalent. So it's time to, understand it, pay attention to it, and when you see it, you can resolve it. Here's the two ECM motor testers I talked about. Genteq TechMake Pro. So you've got your new connections, and you got your old 16-pin. This is a little bit more money, but then you got your Supco over here, which has got your 16-pin and your new 4 connections here. So what I like about an ECM motor tester is if I have that with me and I question whether it's the motor or the module, instead of having me really dig into it, I can unplug the 16-pin or 4-pin connection, plug this in, hook up 24 volts, and I know really quickly whether it's the motor or it's the board. So for $50, I can save myself a ton of aggravation and get right to the root of the problem within seconds, or a trip to the van and back. I always carried mine with me, but the days of struggling to figure out whether it's the motors or the module disappear just with one of these two testers here. So you have your blower motor in your housing. That's how it's supposed to look right here. Nice and shiny and clean. That looks pristine. It is important to understand what kind of motor that you're using. Is it a PSC motor with capacitor? Is it an X13, which is a pre-programmed ECM? Or is it an ECM variable speed? Verify and check your speed taps and or your dip switches and or your thermostat, depending on what you're doing. A big one is verify amperage. It'll tell you on the data plate, and it'll also tell you on the data plate of your motor what your amperage should be, and then verify your rotation. I've come across a few motors in my time where guys have didn't check the rotation on them, so it's actually going the opposite way. You can sometimes you can hear it by sound; it just sounds wrong. But always check your voltage, amperage, and rotation. Same thing with the dual capacitor on the outside. If you've got a blower motor with a capacitor, you also want to test that capacitor as well. And then I'm thinking on verifying your blower wheel is clean. That's how it should be. At least 8 out of 10 times when I did a blower motor, I always sold a blower wheel cleaning as well. So part of that is I would take the motor out, obviously set that to the side, change it, but then completely clean this housing and the motor and the wheel. So that way you're putting a brand new motor on a clean wheel as opposed to a brand new motor on a dirty, filthy wheel. See what time it is here. Okay, well, it's 4:56 my time. If you would like here, let's take about a 10-minute break here. Then we'll come back here and then we'll finish up the rest. So just come back about 10 minutes. So 5:06 or so, 5:07. We'll come back and pick it up. So.